Chapter 11, we're going to be looking at area. In 11.1, we're going to specifically be looking at areas of triangles and parallelograms. So starting simple today. First of all, some of the basics. What is area? Area is the amount of space actually inside a figure, and we're measuring in square units. So area is looking at how many of these square units, whether it's 1 inch by 1 inch or a foot by a foot, but how many of the square units fit inside a figure. So that's what we're talking about when we talk about area. Again, we're looking at units squared because we are talking about actual physical square units. Whereas when we talk about perimeter of an object, we're just talking about the distance around a figure. We're going around the outside, and we're just looking at regular units because we're not talking about area. We're not talking about square units. We're just talking about a distance. Okay, so perimeter is units, whereas area is units squared. This area congruence postulate is pretty profound. If two polygons are congruent, then they have the same area. That kind of makes sense. If two polygons are congruent, they're exact same size and shape, so obviously they have the same area. And then area addition postulate says that the area of a region, okay, some weird shaped figure generally, is just the sum of the areas of the non-overlapping parts. And the word sum tells you to add up just the areas of the non-overlapping parts. So if you had some figure like this, obviously kind of a weird shaped thing, but there's sort of a line I could draw or a way I could split this odd shaped region into parts so I could find the total area. Can you picture where I could draw a line to split this into two very familiar, nice shapes? Well, what if I drew or kind of split the shape right here? Now I have a rectangle, I can find the area. I have a triangle where I can find the area. And if I just do the sum of those areas or add them together, I'll get that total area of this kind of odd-shaped region here. Oh, the point about non-overlapping, just make sure that, let's say you had two rectangular pieces, make sure that you don't overlap the sections. So maybe if you found the area of this rectangle splitting right here, then only find this rectangle here and make sure you're not finding the area of this rectangle, because then you'd be doubling up in this region here. So just be careful with something like that you don't overlap. Let's get some of our basic formulas here. What is the formula for area of a rectangle? And you should know that the area of a rectangle is just base times height, or you can think of it as length times width. Now, the reason why, if I knew that, say, this rectangle was 3 units this direction by 2 units this way, remember that area is square units. If this is a measurement of 3, then I should be able to divide this into its 3 units, right? If that was an inch or whatever, a centimeter, it is 3 of those, and this is 2 of those. So if I look at this side length, it should be divided into 2 of those units. And then if you look, how many square units do I have? Well, physically, how many squares do I have? 1, 2, 3, 4, 5, 6, which obviously is just 3 times 2. It's really easy to see those square units when you think, oh, there's 3 boxes along the bottom, but it's stacked 2 high, so 3 times 2 is 6. So area of a rectangle is kind of really easy to think about, and the reason for the formula is very obvious. When we get to area of a square, just a clarification here, because what do we know about a square? We know that the sides are the same. If I call this side S, then this side is also S, and I'm just using S because it is a square, and we can talk about the side. So in this case, S times S would just be S squared. Okay, whatever that side length is squared. If it was 5 by 5, it's 25 for units squared for the area. So what about the area of a parallelogram? Okay, remember that a parallelogram has those opposite parallel sides, congruent parallel opposite sides, congruent opposite angles, and all of those other properties we had, but what's the area of a parallelogram? How many square units would fit inside this? Well, here's what we're going to do. Is there a way that you can picture, could I turn a parallelogram into a rectangle? Is there a way that I could kind of alter this, physically change the parallelogram to make it look like a rectangle? Hopefully some of you are thinking, maybe if I drop a straight line here and actually cut out the triangle that I form, and I'm thinking I'm going to remove that triangle. I'm going to cut this portion out and I'm going to slide it. Maybe I'll copy and paste it. and I'm going to slide it over here. Well, now if I'm actually going to remove this part doesn't exist. To the left, this is gone. But I've now made a rectangle. If I slid that triangle over here, I've preserved the area because you just moved something to a different spot. Now you have a rectangle. Well, the area of a rectangle is just base times height, and the area of this parallelogram becomes a rectangle, so it is just base times height. Now you might be questioning, first of all, how do you measure the height? Well, it has to be at a right angle. Okay, so when you're talking about the height of a parallelogram, it must go at a right angle between the bases. Whether you measure here or here, that height's the same. Also with the base, you see that the base doesn't change on top. It looks like the base kind of changed on bottom, but really I just shifted this portion here. So the base is the original base of that parallelogram. And technically, area of a parallelogram is the same as a rectangle, as long as the height's at a right angle. And then finally, can we turn a triangle into a parallelogram? Now I'm hopping back this step and I'm saying, can I make a triangle into a parallelogram so that I can come up with an area formula I already know? There is a way to make a triangle look like a parallelogram. All you have to do is take a triangle, copy and paste. I'm going to bring this triangle over and rotate it. Match up one of its sides and set it down on itself. And you notice now the entire shape is a parallelogram, right? The original triangle is sitting right here. Well, now I have a parallelogram. Now I know the area of a parallelogram is just base times height. This entire parallelogram is whatever the base is here times whatever the height is. Remember that the height would have to go, okay, that's horrible, at a right angle to the side. I guess in this case, if I was looking at the original triangle, I'd probably drop my right angle down here, but I have to extend that side. The problem is if I just say the area of that parallelogram is base times height, that's not my one triangle, that's two triangles. So really I don't want the area of the whole parallelogram, I only want half of that because I just put two triangles to make that parallelogram. So area of a triangle is 1/2 base times height, as long as the height is measured from the highest point or from a vertex to the opposite side at a right angle, also called an altitude if you remember back from when we talked about altitudes, same as the height. So now we have our basic area formulas for today. Let's try and use those. Here I'm finding perimeter and area of each of these polygons. Now first of all, we know with perimeter you just add up all the sides or the outside of the figure. So if I want to do perimeter of this triangle, I'm only looking at the outsides and the side lengths there, and you're adding those together, 17 plus 10 plus 21, and it looks like, what do we have, 48? And there are no units given. Perimeter is just a distance, so I'll just say units there. Okay. What about area? What's the formula for area of a triangle? It's 1/2 base times height. So I'm doing 1/2 times the base times the height, whatever those are. Well, if you look in this triangle, it looks like the only height or altitude I'm given is this 8, and if that's the height, the base is where this meets that side, so the base is 21. The height is 8, so 1/2 base times height, and it looks like I'm getting 84. They didn't give me a units like inches or feet or anything, but I'm going to write units squared, of course, for area. Alright. What about here? First of all, what shape am I dealing with? Well, if you look at the parallel opposite sides, this is a parallelogram. Oh, and also this helps because if I'm supposed to find the perimeter of this parallelogram, I got to know all the side lengths to be able to add them up. And I was only given 30 and 20, but if it's a parallelogram, we know the opposite sides are congruent, so I have another 20 and another 30. So I'm just going to multiply this by 2, because I know there'll be another 30 here and another 20 here. So it's really 50 times 2, right? 30 plus 20 is 50 times 2. 100, no units given, so I just write units for perimeter. And then what's the area of a parallelogram? It's just the base times the height. The base in this case would be considered 30, and the height 17. This is a height because it goes between the bases at a right angle. So base of 30, 17 would be the height between those bases. And 30 times 17 is 510. Area is units squared. Alright. One of the more interesting shapes that you're going to get today is a right triangle, as we see here. Right triangle because I see the right angle. And the cool thing is that with a right triangle, I know when I'm doing area of any triangle, area is 1/2 base times height. And with a right triangle, because a height has to go from a vertex at a right angle to the opposite side, you can consider one of the legs the height. Look, it's going from vertex to opposite side at a right angle. And the other leg can be the base. So this is always the case in a right triangle. The base can be one of the legs, the height can be the other leg because they meet at a right angle by design. The only problem here is I don't have the base. I'm missing the leg of this right triangle. Well, good thing I have Pythagorean theorem, right, to find that missing leg. In this case, I have the hypotenuse is 13, one of the legs. So I'm going to do hypotenuse squared minus the leg squared I have. Right, because I know it's leg squared plus leg squared equals hypotenuse squared. So I'm going to do hypotenuse squared minus the leg squared. And that equals my other leg, which I'm calling b for base squared. Now 13 squared minus 5 squared is 144. And that equals that base of the triangle, the other leg squared, and I will square root that, of course. And it looks like the base in this case is 12. The other leg is 12. Square root of 144 being 12 there. And now when I do the area, 1/2 base times height. Again, the base and height of a right triangle can be the legs. The base I'll call 12. And the height then going at a right angle to that side is 5. It looks like the area is 30. No units were given, so just units, and its area, so units squared. Okay. Oh, and finally, I guess I need to do perimeter for this right triangle here, and I add up all the sides. 5 plus 12 plus 13, adding up those three sides there, and I'm getting, oh, also 30 units squared. Okay, I screwed up. This is perimeter, so it's just units, of course, not units squared. Perimeter is just a distance around. Okay, so using some more basic area formulas and talking about perimeter there. This is an interesting one. In this case, the parallelogram is in this pinkish color here. And I want to find the area of that parallelogram in two ways. Well, and there are two ways to do it because you can consider either side of the parallelogram as the base here. I know the area of a parallelogram is base times height. And probably the way that you're first thinking of it as, well, 35, let's consider that the base, right? Now, if 35 is the base, what's the height of the parallelogram? Well, if 35 is my base, I'm trying to find the distance between the two bases at a right angle. Oh, the distance between these two bases, if 35 is the base, is actually over here, and it's 20. And that's going at a right angle between the bases, is like an extension of that side. So if 35 is the base, 20 is the height, it's a distance between the bases. And 35 times 20 would be 700 then. And again, it's area, so units squared. But the other way to think of it is, what if 25 is the base? Well, then I need the distance between these two bases at a right angle, right? If 25 is a base, then these are my bases. What's the distance between? It's actually drawn out here. 28 would be the distance between the bases. This 25, this base is like extended out here. And 28 goes at a right angle between them. So in that case, area's base of 25 times the height of 28. And I'll check on the calculator, but I should get 700 again. Obviously, it's the same shape. It should have the same area no matter what way you find it. And it is, once again, 700 units squared. So I was able to look at like each of the sides of the parallelogram as being a base and finding the height between base and the height between, and get that formula two ways. So that was kind of neat. These examples are actually finding a variable. You'll know the area, and you have to solve for in a base or a height or something like that. So let's see here. The base of a triangle is half the height. Base of a triangle is half the height, so it's really tall. Actually, I feel like it should be even taller than. The base is tiny. The base here is half of the height. Remember, the height goes at a right angle to the side. The area of the triangle is 64 centimeters squared. Find the base and height. Well, area of a triangle. Okay, if I'm trying to find an unknown, I need the formula. So I know area of a triangle is 1/2 base times height. And the area is 64 centimeters squared, so area equals 64. I know that for sure. It's 1/2 base and height. Well, I have to find a way to call base and height with the same variable, basically, because otherwise I'm not going to be able to find this. I don't have the base or the height, but I know the base is half the height. So I'm going to get rid of these variables. If I call the height x, how about? It said the base is half of the height. So if the height is x and the base is half of that, wouldn't the base be 1/2 x? That should make sense, right? Base is half of whatever the height is. So this is x, this is half of x. Now when I do 1/2 base times height, I know I'm calling the base 1/2 x times the height is just x. Oh, remember this half in front is because it's 1/2 base times height. The base is 1/2 x, the height is x. Well, let's see what I've got. 64 equals, these are all being multiplied. Let's multiply things together. What's 1/2 times a half? I'm just multiplying fractions, multiplying numerators and denominators. Half times a half is 1/4. X times x is x squared. This is a fraction multiplied by the reciprocal. Here, really just multiplying by 4, right, to make that cancel. 4 times 64 is 256. And that equals my x squared. Undo squared by taking square root, and I'm on my way to finding that x there. Now square root of 256, that is a perfect square. The square root of 256 is 16. So what are the base and the height of this triangle? Well, if x is 16, the height then, and I'll do h equals, is actually 16. Now what's the label? Area was centimeters squared, so the height must have been in centimeters. The base was half of the height. Height was 16, half of 16 would be 8, also in centimeters. And we can check, is the area really 64 centimeters squared? If I did 1/2 base times height, is that 64? Yes, 1/2 8 times 16 is 64, and you're good to go. Alright, another example, we're finding a variable here. A parallelogram has an area of 153 inches squared. The height measures 17 inches. Okay, I know the height. Remember that goes at a right angle to the base. 17 inches. Find the base. I don't know the base. Alright. Well, I do know we're dealing with a parallelogram. Have the area. What is the area formula for a parallelogram? Well, area of a parallelogram is just base times height, isn't it? I know the area. It's 153 square inches. That should equal base times height. I don't know the base, but I know the height is 17, so base times 17. All I need to do is 153 divided by 17, and it looks like the base is 9. And what the label be, area was inches squared, so the base would be 9 inches because it's just that measurement or that length. So looking here how to solve for an unknown variable when you're given the area. And one more example, looking at a real life thing. You are painting an A-frame house. Here's the front of your house and a deck. We know 1 gallon of paint covers 275 square feet. 1 gallon equals 275 square feet. How many gallons of paint do you need to cover this house? Well, if you think about it, if you're painting, what kind of measurement are you looking for? And this gives you a hint with the feet squared, but I need area, right? If you're going to cover space, you need to know how much space is inside the thing you're covering. We need area here. So I need the area of the front of the house. I need the area of the deck. I guess the problem here is that the front of the house is a triangle, and I know that for the front of the house here, if it's a triangle, the area of a triangle is 1/2 half base times height. Right? That's the area of a triangle. But to do the area of that triangle, I need the height and the base. I'm drawing this in. This will be my height. What's the base? Oh, well, the deck, I'm assuming, we see the right angles. It's a rectangle then. So this is also 30 feet. So I know the base of the triangle, but I don't know the height. Well, here's the extra info I do know. I mean, if this is a house, then this is an isosceles triangle, and if this is 38 feet, so is this. And we've talked about how in an isosceles triangle, an altitude, which a height is also a median, a perpendicular bisector, and, well, an angle bisector too. So we are splitting this side in half. If this whole base is 30, then this is 15, and so is this. Which means I now have a right triangle, and I can find the height here. Right? Using Pythagorean theorem, 38 is my hypotenuse. I have 2 legs. So I know since I have the hypotenuse is 38, I'm going to do 38 squared minus one of the legs, which is 15 squared. And that equals the height of that front of the house squared. So 38 squared minus 15 squared is 1,219. And that equals the height squared. Fairly certain this is not a perfect square. We're going to get a decimal here, but that's okay. It looks like the height of that house is 34.91. Now I'm going to leave this answer in my calculator to keep it accurate. All these were in feet. Okay. Let's find the areas I need. Now the area of the house. Since it is a triangle, and we know the area of a triangle is 1/2 base times height, let's do that. The base of the triangle of the front of the house, the whole base was 30. Make sure you are taking the whole base, which is 30, times the height, which is the number I have sitting in my calculator. I'm going to use the whole thing, the 34.91 approximately. So I'm going to do that times 30 times 1/2. And for the area of the house, I'm getting 523.71 to 2 decimal places there. And this is area, so feet squared. Kind of circling that because that's important. We're also covering the deck. So what is the area of the deck? Well, it's a rectangle, right? It's 9 by 30. So 9 times 30, 270 square feet, because we're talking area. So total area. I'm going to add these two together. I need the total area that we are painting. It is 793.71 square feet. Last thing then, we know that 1 gallon covers 275 square feet. Well, I'm definitely doing more than that. I'm going to multiply by conversion here. I know that I want to figure out gallons. I want feet squared to cancel. I'm going to put feet squared on bottom then. Gallons on top. And I know that 1 gallon, this fraction is going to basically be equal to 1 because these things are equivalent. 1 gallon covers 275 square feet. Square feet cancel because it's on top and bottom. So basically I'm taking the 793 that I have in my calculator, dividing by 275. And now I get 2.89 gallons. But I really don't think I can buy 2.89 gallons at the store. So I guess my final answer here, I'm going to need to buy 3 gallons, rounding up to the nearest gallon, when I go to the store. So today, looking at area of our basic shapes, rectangles, parallelograms, and triangles.